All right, so in this lesson, we're going to be reviewing the conversions between grams, which is mass, and moles. In the last lesson, we talked about the molar mass of compounds. Well, remember, the molar mass of a compound is the mass of 1 mole. So it's in grams, that's the unit for mass. So it's how many grams are there in 1 mole of compound. Okay, remember that 1 mole of something is 6.02 times 10 to the 23rd atoms or molecules or anything, but for us it means atoms and molecules. So what we're really saying is that the molar mass of a compound is how much 6.02 times 10 to the 23rd atoms or molecules of that substance would weigh. Okay, or again, to do it backwards, if you weigh out whatever the molar mass of a compound is, or an element, then that means that in that one group of grams, however many grams it is, you would have 6.02 times 10 to the 23rd particles. Okay, now we use these numbers because atoms and molecules are so small that we need to group them into these bundles that are something that we can work with, we can see and measure and touch and manipulate, because the atoms and molecules are so small that we can't even see them really, much less work with them on an individual basis. Now, going forward, this concept of the mole and molar mass will allow us to compare parts of a chemical reaction. Okay, but for now, all we're going to do is we're going to review how to convert between moles and molar mass, and in both directions, going from moles to molar mass, moles to mass, and mass to moles. So, how do we find the molar mass of a compound? Just a quick review. All right, so we find the molar mass of Na3PO4, which is called sodium phosphate. Okay, and in order to do that, we find the mass of each element in the compound. So in this compound, there are 3 elements. Remember, every capital letter means a different element. So there's sodium, phosphorus, and oxygen. So there's 3 different elements that we're going to look up, and then we're going to multiply the subscripts in the formula, which I covered up a little bit. There's a 3 and a 4 in here. We're going to multiply those subscripts times the mass of each element that they apply to. So let's take a look at that. We need a periodic table. Okay, so we'd say, all right, sodium. Sodium is here. It has a mass of 22.9, okay, which we usually round up to 23. There's a subscript of 3 next to that sodium, so we say it's 23 times 3, which is 69 grams. So 3 moles of sodium has a mass of 69 grams. The next element on here is phosphorus. Okay, phosphorus has a mass of 30.97, which we'll round up to 31. Now phosphorus, remember it's just P, there's no number next to it, so there's only one of those, so we can just say the total for phosphorus is 31 grams. And then finally we have oxygen, which we say is 16 grams for 1 mole. But because of the subscript 4, we multiply that by 4, and that comes out to 64 grams. So when we add all that together, we get 164 grams for the molar mass of sodium phosphate. So that's where we would have stopped in the last lesson. Okay, so it tells us that 1 mole of sodium phosphate weighs 164 grams, or 164 grams equals 1 mole. So you can do it either way. You can measure it or compare it either way. Now, of course, in a lab and in chemical reactions, where we're going to look at equations in the next section, you don't typically have just exactly 1 mole of something. Right? Chemical reactions require multiple moles or multiple groups or units of things, and when we measure stuff out in the lab, it would be very unusual to measure it out and say, oh wow, that's exactly 164 grams of sodium phosphate. But when we're working with amounts that aren't 1 mole, we can still use the molar mass to do calculations on either how many moles we have or how many grams we would have. So here's what we're going to do. Okay, if 1 mole, let's say we have a reaction that requires 3 moles of sodium phosphate. Well, we know 1 mole is 164 grams. We just figured that out. So how many grams would you have if you have 3 moles? Well, that's 3 times as much as 1 mole, right? It's a proportion. So if 1 mole equals 164, then 3 moles equals 3 times 164, which is 492 grams. Okay, so 3 moles of sodium phosphate is equal to 492 grams of sodium phosphate. So when you are given moles and asked for grams, you multiply the number of moles times the molar mass. Okay, that's the process. Take the number of moles you're given, multiply by the molar mass, which you'll have to figure out if they don't give it to you. But we've already done that. We've already done calculating molar mass. So you calculate the molar mass and then multiply it by the number of moles that they give you. Okay. Now let's say that we have a sample of sodium phosphate. We'll stick with the one we have already done. And we measure it out, and we find that it is 328 grams. We want to know how many moles that is. Well, we know 164 grams is equal to 1 mole. So how many moles is 328? Again, it's a proportion. It's just now we're going in the reverse direction. So we take the number of grams, 328, and we divide by the number of grams that equals 1 mole, which is 164. So the molar mass. That equals 2 moles. Right? So if you look at it, 328 is 2 times 164. Right? It's double the amount. So it makes sense that we have double the number of moles. We have 2 instead of 1. So when you're given grams and asked to find moles, you divide. Okay? So that the only difference here is going from moles to grams you multiply, going from grams to moles you divide. In both cases, the number that you're using is the molar mass of the substance. Okay? It's just a matter of whether you're multiplying or dividing by that number. Okay? So in the examples that we're going to look at, they won't be round numbers. Okay? There's going to be decimals. There'll be some numbers that are less than 1, like 0.08 and things like that. It doesn't matter what the number of moles is. And it doesn't matter what the number of moles comes out to. There's no rule that says it has to be 1 or more. When you have a number of grams, you could have, a tenth or 100th or even 1,000th of a mole, depending on the number of grams and the molar mass. So, step 1, find the molar mass of the element or compound. If you are still struggling with that or need a review of that, go back and watch the last lesson from yesterday, and that will show you how to find the molar mass of compounds and elements. Okay? So then the rest of it is just deciding which direction you're going to go. If you're given moles, if it says you have X number of moles, how many grams would that be? So what are you being given and what are you being asked to find is how you figure out what the next step is. If you're being given a number of moles and asked to find grams, if the question says how many grams, then you multiply the number of moles times the molar mass of the compound. If you're given the grams and asked for moles, if the question is how many moles, then you divide the grams, the mass that you're given, by the molar mass of the compound. Okay, so it's either one or the other. So let's take a look at a few of these. Okay, convert 6.501 grams of helium to moles of helium. So what are we given? Okay, well, we're given grams, we're given mass, and it says convert to moles. So our answer is going to be moles. So when we're converting 2 moles from grams, we take the number of grams we're given. Oops, that should be a 1. And we divide it by the molar mass. In this case, it's helium. Okay, helium has a mass of 4 grams per mole. So when we take that 6.5 and we divide it by 4, we get 1.625 moles of helium. Okay, and if you're, worried about rounding, especially, if you get into really big, long decimals, it's always okay for me if you wanted to round off at the second decimal place. So in that case, it would be 1.63 if you wanted to round that off. That's okay. And that's moles. Make sure you put the unit in there. All right. Convert 0.075 grams of Pb, which is lead, to moles of lead. So again, we're given grams, we're given the mass, and we're trying to find moles. So we take the grams we're given. Now this is a really tiny number, right? Less than 1/10 of a gram of lead. And lead, which is down here near the bottom of the periodic table, it has a mass of 207, and I'm rounding, 207 grams. So this is going to be a really small number because it's already a small number, and then we're dividing it by a fairly big number. So take 0.075, divide it by 207, and we get 0.00036, and it goes on. Okay, I'm rounding. Moles. So that's 10th, 100th, 1000th, 10, that's 3 10,000ths of a mole, which is a really small number, and it's a small amount, right? Think about lead is dense, it's heavy, right, when you think about lead. So if you only have less than 1/10 of a gram, you're going to have way less than a mole of lead, because a mole of lead is over 200 grams. So again, these numbers can be anything that they want to be, right? There's no set rule that says you have to have a certain amount. All right, now we're going to convert 4.36 moles of barium, Ba, to grams of barium. Okay, so let's see. We have 4, I'm going to zoom in here a little bit, 4.36 moles, and then we're going to multiply that times the molar mass, because when you go from moles to grams, you multiply times the molar mass of barium. This is just an element. All right, so 137.33. All right, these are all elements so far, so we haven't had to do a compound. But 4.36 times 137.33 is 598.76 grams. Okay, so again, a mole of barium by itself is over 100 grams. So if you have 4 moles, it's 4 times as much, right? So it's got to be at least over 400. And do the math, and it comes out to actually almost 600. Let's take a look at another one. Okay, so again, just looking at elements just to kind of get the process down without having to add the extra step of calculating molar mass. So 3.26 moles of chromium. So again, we're starting with moles, and we're going to grams. So we're going to multiply 3.26 moles of chromium. Chromium is right here on the edge of our screen. It's got a mass of 52. Okay, so times 52 grams of chromium. So 3.26 times 52 is 169.52 grams of chromium. Okay, now let's take a look at doing this with a couple of compounds. The conversion process is exactly the same. We're either multiplying or dividing by the molar mass. The only added piece here is that since we have a compound like H2O, instead of just a single element, we're going to have to first calculate the molar mass by adding up all the elements. Again, you can review the last lesson if you're still struggling with that, or just want to review it. And then we either multiply or divide. Okay, so we're given grams here, and we're converting to moles. So when you're given grams and you're converting to moles, you're going to divide. So first, though, we need to figure out what's the molar mass of H2O. Well, remember H, hydrogen, has a mass of 1. And because of the little subscript, we multiply that by 2. So that means there's 2 grams of hydrogen. And then oxygen has a mass of 16. Since there's only 1, that's 16, which means the total molar mass for water is 18 grams per mole. And according to the problem, we have 4.5 grams. Okay, so at a quick look, hopefully you can see, well, 4.5 grams is less than 18 grams, so our answer should be less than 1 mole, because we don't even have 18 grams worth. We have, basically a quarter of that. So if we do 4.5 divided by 18, we actually have exactly 0.25 moles. Right? 4.5 is 1/4 of 18. And that's of H2O. Okay, convert 3.45 moles of NH3, which is ammonia, to grams. So this time we're going the other way. We're converting from grams to from moles to grams, but we still need to, we have a compound, so we need to figure out the molar mass first. So we have nitrogen, which has a mass of 14, and then we have hydrogen, which has a mass of 1, but there's 3 of them, so we multiply that by 3. So 14 plus 1 times 3 is 17, right? 14 plus 3. Okay, so 3.54 moles times 17 grams, and that's per mole. 3.54 times 17 equals 60.18 grams of ammonia. Alright, so convert 6.05 grams, 0.045 grams of barium sulfate. Okay, so we're converting from grams to moles. So let's look at the molar mass. We've got barium, which is 137.3, plus sulfur, which is 32, plus oxygen. Oxygen is 16, remember, times 4. So 16 times 4 is 64. So let's add all that up. 0.3, 233.3 grams. That's the mass of 1 mole. We have grams, so that means we're going to take the number of grams we're given. We were given a number of grams to work with. We're going to divide that by the molar mass. Okay, so it's 6.045 divided by 233.3. And that comes out to 0.026, I'm rounding, moles. Okay, so again, when you look at it, a mole of barium sulfate is pretty heavy, 230 grams. you only had 6 grams. So you should have way less than 1 mole, which you do. You have, less than a tenth, right? You have 2/100ths of a mole. All right, 45.66 grams. Okay, again, always look at what are you given. You're given grams. We're converting to moles, so we're going to be dividing by the molar mass. It's a compound, though, so we have to figure out the molar mass first. So iron, it's in the middle here. Iron is 55.85. I'm just going to leave that as 55.85. Sorry, 55.85, not 58. Okay, and then we have oxygen and hydrogen times 3. So you can do this either way. You can add the oxygen and hydrogen together in the parentheses and then multiply it times 3. Or you can do the oxygen times 3, the hydrogen times 3, and then add those two together. It works out the same either way. The oxygen is 16 times 3 is 48. The hydrogen is 1 times 3 is 3. So now we got to add all this together. We've got 55.85 plus 48 plus 3. So let's just add that together just to be sure. 55.85 plus 48 plus 3 is 106.85. Okay, there's your molar mass, 106.85. We were given 45.66 grams. The molar mass is 106.85 grams. So again, remember what that means. That means that 1 mole of this stuff would weigh 106.85 grams. What we have, is less than that. It's pretty close to half. Right? So the number of moles we get should be close to a half, or 0.5. So if you do the math out and you get a number that sounds close to that, just kind of eyeballing it here, then that gives you a pretty good idea that you ended up in the right place. So I'm going to round this actually to 0.43. Right? So remember we said it should be close to a half. That's pretty close to a half, 0.43 moles. So there you go. That makes sense. You had about half a mole of stuff. Okay, let's just do a couple more. Convert moles to, so now we're starting with moles and we're going to convert to grams. So we're going to multiply the 3.18 moles times the molar mass of CuCl2. So let's go look at that. Okay, Cu is here. It's 63.55, and I'm going to leave it like that. And then chlorine is 35.45. And then actually this is CuCl2. So I have to add that in twice, or you could have multiplied it by 2. Either way it works. Okay, so we add all that together, 63.55 plus 35.45 plus 35.45 equals 134.45 grams. That's 1 mole. Back over here, the question says we have 3.18 moles. Well, if 1 mole weighs 134.45 grams, well then 3.18 moles should weigh a little more than 3 times that much. And that comes out to 427.55, rounded the wrong way, grams. Okay, that's how much 3.18 moles would weigh. And then last one, okay, 0.0083 moles of HCl, hydrogen chloride or hydrochloric acid. Okay, so this is a very small number of moles, 0.0083 moles, times the molar mass of HCl. Well, we know H is 1, and then chlorine, which is over here, is that 35.45. Okay, so 1 plus 35.45 is 36.45 grams. So 36.45 grams. That's how much 1 mole would weigh. We don't have 1 mole. We don't even have close to a mole. We don't even have a tenth. We don't even have a hundredth. We have a little less than 100. We have 8 thousandths. Okay, so if we multiply those together, we do 0.0083 times 36.45. We get 0.30, and I'm going to round it there, grams. Okay, so less than half a gram, 0.3 grams, is what 0.0083 moles would weigh. Okay, so that wraps up today's lesson. And then what we're going to be looking at is how, in the next lesson, the next section, okay, we're going to take all this stuff that we've been doing, converting from moles to grams, calculating molar mass, identifying all the elements in a compound and how many of each element there are, and we're going to use that to look at chemical equations and do a couple of things. First of all, we're going to do what's called balancing the equation, which just means you got to make sure that whatever you've got at the beginning of the reaction, in terms of the atoms, the number of atoms of each element, is the same as the number of atoms of each element that you end up with at the end of the reaction. Okay, because the laws of chemistry say atoms don't just disappear during a reaction, they get moved around. So whatever you've got at the beginning is the same as what you've got at the end in terms of atom. They've just been rearranged. So that's one thing we're going to do, looking at the formulas and the coefficients, which we touched on a little earlier in another lesson. And then the next step beyond that is using those balanced equations and converting from grams to moles and moles to grams to figure out either, depending on how much stuff you start with, what you end up with, or if you know how much you want to end up with, you can figure out what you need to start with. So in those cases, those are like recipes, right? The chemical reaction, the chemical equation is like a recipe for a reaction. And just like in a recipe, you can measure out the ingredients and predict roughly what you're going to get out, how many cookies you're going to make based on the recipe you're using and the ingredients you have. Chemical reactions are the same way. If you know how much stuff you're starting with and you know what the recipe is, you can predict how many, chemistry cookies you're going to get at the end. So that's the plan. That's, looking ahead a little bit. We'll have one more lesson this week of review. And then hopefully, plan is that Friday will be something a little bit different. And then going ahead till next week, we'll be looking at some new material. But I'm waiting for some information. So stay tuned for that. I'll post something as soon as I know what the plan is. But we will, at some point, be moving forward into new material. We'll take it slow. We'll do a little bit at a time, and we'll get there. All right, stay safe.